Okay. All right. Thank you. So today we have minor project 2, and we'll be looking at these 4 topics in major to do our minor project 2. So we already had 2 sessions of stellar evolution, sessions of galaxies, 2 sessions of compact objects, and we had 1 session of cosmology, and we'll have one more session of cosmology on Monday. So you will have a total of 8 sessions, out of which you'll be working on this project, right? Okay. So this project is all about testing how much you understand these topics and how much of a depth you want to go into while you research on these topics further, right? So since astrophysics, as you all know, is a very vast subject, um, I couldn't obviously cover a lot of topics, right? So I've given you a gist, or rather a taste of all these topics. I've introduced you to a few topics, basic topics, few advanced ideas, few concepts, and given you a couple of assignments as well. I hope everyone has submitted your assignments by the 3rd. I've started looking through those, but uh, I saw some people updating or uploading their assignments even after the 3rd. Yes, so I'm still looking through the people who have uploaded after the 3rd, but ideally I will not be doing that hereafter. But I am considering this time because, as I promised last week, I couldn't take a session on last Friday or the Monday because I had to travel immediately due to a family emergency. So I just came back yesterday. So this is the first session we are having. So due to that, I'm considering all the assignments that came even after that, because I'm sure you must have had a few doubts which you couldn't clear with me before the deadline. So this is it up till 5th, or maximum till yesterday's. I'll be looking during this weekend, and that's that. I may not be able to check the assignments that are being uploaded after that. Anyway, so from that, we have come to this minor project 2, which is your, out of the 3 main projects you have for the entire workshop, this will be the second one. The first one, hope you remember, was the HR diagram. So this is your minor project 2, and this is all about researching and presentation, right? So as I've already mentioned, it'll be based on these 4 topics in general. So it is called astrophysical synthesis, and this is more research oriented. And yeah, so so our previous activities have more or less focused on some very specific concepts, right? Like we had based on the Hubble tension, and we had based on um, the HR diagrams, we had based on some contradictory stars, symbiotic binaries, etc. Now, this is more generalized because I'm giving you a vast area to cover upon, and you can choose your favorite, or you can choose the topic that you want to be researching on further, and then you can present, right? So the entire focus of this project will be on synthesis. So like you do synthesis back in your school or in college, you will be doing the synthesis on astrophysics as well. So that will be mainly about connecting the dots between some different vast scales and concepts of our universe. Right. Yeah. So you have about 2 weekends, as in you have um, exactly 10 days to prepare from today. That's why I thought of giving this project introduction today itself rather than wait till the end of the weekend, so that you can start looking into the topics during the weekend if you'd like to. We have one more topic that, one final topic that we'll be looking into based on this project on Monday. But by then, you should be able to cover most of the other topics that is given for this project, right? And some briefs that I would like to give you here are: you will be preparing a research presentation, and each person will be allotted a maximum of 8 to 10 minutes. You can have a 5 to 10 minutes in a broader way, and this is the maximum time. try your best to convey all the topics or all the concepts within this timeline. And yeah, you should be very concise while you present your topics, because the time limit we would be constraining, because we only have 2 hours for all of you to present. So it's best to stick to maximum of 10 minutes, right? So for this project, your core objective will be to demonstrate your demonstrate the kind of concepts that you're more inclined to, or more the topics that you're more inclined to, with an advanced understanding of how the basic 4 pillars of our courses, from minor project 1, how far we have come, all those 4 topics that I've mentioned in previous slides, that is stellar evolution, galaxies, compact objects, and cosmology. So how you will be inculcating these 4 major topics into your course, and how your understanding has evolved around these topics. Now, I will be providing you with 5 synthetic topics, and you can choose any one topic and you can continue with that. You just have to choose one topic and you can do your research and presentation over that topic. So, if you're wondering what a synthetic topic is, synthetic topic is basically a term that you would be um, facing or encountering a lot when you do theses, etc. So synthetic topics are nothing but it's the one that cannot be explained by just looking at just one field. So synthetic topics usually inculcate a lot of topics. So my idea here for this project is also similar. So we have 4 topics, and I have 4 major topics, and I've given you 4 major concepts that we have discussed about, and I'll be giving you 5 topics, and each of these 5 topics will have at least 3 out of 4 concepts inculcated. Now, might sound a little confusing. You will understand when we go as into it. So this is what is called a synthetic topic. So this should further help you in any field that you work in, because you may be having a lot of concepts or a lot of subtopics dealt with in your course. And when you have to research on something, it's always best to touch at least 3 to 4 topics out of what you have learned. So that will give you an idea about interlinking your topics with each other, as well as to look at it in a more advanced manner. Right. So, yeah. So, for example, to give you an example of a synthetic topic, okay, apart from these, like how a concept from stellar evolution is directly impacting the cosmological measurement, right? So something about stellar evolution is being applied into the cosmological overview. So there you're covering both stellar evolution as well as cosmology, right? So there, that is inculcation of 2 topics. So that will that will be how this project be working. So your evaluation will be based on the research depth and the clarity, and most importantly, how successful you are in weaving these different concepts together, and how you can focus on one and you try to inculcate both the other topics into it, and you can be creative around it. You can explore the topics, you can play with it, you can have fun however you like. But the only concept here is how successful you are with expressing your topics in a concise manner within the time limit, as well as how effective your research is while you express it, right? So moving on. Now, what the relevance is, or why are we doing this project? Just to give you sort of an idea, apart from uh, the procedural part of the project, in astrophysics, what's the relevance? Relevance, sorry. So basically, in the modern astrophysics, um, we should understand that no topic is an island. Like, no topic is isolated. It's always a set of topics that come together to give you a conceptual understanding when you deal with any kind of astrophysics branches, or any kind of sub topics in astrophysics, right? So, stellar evolution, for example, it doesn't just end with the evolution. Now that will automatically, a stellar evolution will continue in such a way that once it is evolved, once a stellar evolution has happened, or once a star has been evolved, it will create some compact objects. Now these compact objects could be like white dwarfs or neutron stars, as we have already learned about. Now those compact objects are not just, you know, just dead means. Now a white dwarf could be a part of a binary system, and it can explode and become a type 1a supernova. So from the supernova, it could be a supermassive black hole, and it can link to AGN, and that AGN is again an engine of galaxies. Now that will give you some feedbacks on the shape, structure, etc. And these events also have some cosmological significance to it, because the type 1a supernova, as we have already mentioned, is a standard candle to all our researchers when it comes to supernovae. And we used to measure the expansion of the universe and prove the existence of dark energy with this. Now the dark energy and the lambda CDM topics will be taken on Monday, but hope you all have a sort of idea about what dark matter is, as we have already discussed. So all these are interlinked, interconnected, so you can't really just understand one aspect alone. When you understand cosmology, you come from the stellar evolution and compact objects, and what these compact objects lead into, and what those leads into. So everything is interconnected. So out of these four topics, it's compulsory that you need to choose at least three to interlink with your topic, right? Yeah. So let's um, yeah. So before we make those connections, I'll help you understand your topics. So these are the 5 topics that you will be getting. Mm, Um, okay, I'm just trying to make sure if the video is being recorded, if the session is being recorded. I don't think the session is being recorded. Uh, it's, does anyone know how to get the session to be recorded? Or can anyone start recording if that's possible? Someone? Guys, am I audible?
Yes, you're audible. Just trying to find.
Yes, ma'am, you are. But I
Okay,
don't
then,
think we can do that.
all right, if you can tell me the steps, I can maybe check from my end. But I think it's open to all, so shouldn't be a problem. Where do you usually have the option to record? Okay, no, recording unavailable. You're not allowed to record this video call. All right, I'll just click a picture quickly and okay, cool. Yeah. Okay, so going back, I think those who have missed this session has missed it. Anyway, I'll brief it in the group for your quick reference as well. Yeah, well, coming back. So we have these 5 topics, as you can see. Um, so here we'll be, so I'll give you a quick philosophy behind why these topics are chosen. And so, first of all, they are sort of designed to test the synthesis. Like, you cannot successfully present any of these topics by just opening one slide deck. Like, for example, as I've already mentioned about standard candles, for this you will have to require for this you will have to explain stuffs like white dwarf physics from compact objects, and you will have to discuss about lambda CDM from cosmology, and you must build the sort of, you know, logical chain that connects all of these. And second of all, you will have these topics to be the frontier, because we are not asking you to solve problems that, that was already solved in 1950s or earlier astrophysical age. We're asking you to actively research on some unsolved puzzles, and not to find answers but to have a deep understanding about those, because you have ample amount of articles and materials out for you. And if you have any, if you could go beyond, what do you say, if you could go to a better extent, I'm sure there are a lot of libraries around you, and you can even check from there if Google is not able to provide enough. Because not every documents or not every books of astrophysics are yet published online. So try to refer books if possible, or refer online documents or articles, publishes, etc. Now, they also require the sort of quantitative context, right? You can't just say dark matter exists and just end it there. You must explain how flat the rotational curve is, like how we checked in our previous classes, and or the CMB power, or the power that the spectrum provides, and all of these have to be there, like how the quantitative approach can be more effective to convey your concept. Now, this quantitative approach for your context is an advanced level requirement that I'm looking into when I'm going through your presentations, because that will make me, as well as you all and the other students, understand how far you have gone into the depth of a context, right? So as a group, these topics should cover a lot of cosmic story that you can link together and have a good understanding about. And since we are starting from the stellar evolution, that is the very first star's evolution and the ultimate cold end of the universe, so we have the whole the whole analogy of it, like from the beginning of the stars to the fate of the universe. The fate of the universe part will be taken in the upcoming session, so please make sure that you check that as well to have a better understanding about the topics we are taking today. So yeah, so this is one of the grandest scale that you can go into, because we are covering from the birth to the ultimate fate of the universe, sorry. Yeah, so let's look at the first two topics. So topic one is called the type 1a supernovae, or the cosmic tools. So here it's about two main types of supernovae. So you will be tracing how a star's life or a stellar evolution will lead to type 2 supernovae, which will create a neutron star that is a compact object, and how a type 1a also from compact object is used as a tool to measure the universe. So here, as you can see, the synthesis I'm collecting for this first topic is stellar evolution, compact object, and cosmology, right? And I'll be giving you these screenshots so you can check what are the elements that we'll be considering while we look into your presentation. So these are some of the important terms that you may require, or important terms, or rather some exclusive points that I'll be specially noting down when you do your presentation. And your second topic is about the invisible universe. That is, we have mentioned about around 85% of the entire universe being dark matter. So it'll be about that. You can take from Halo to Horizon, and it'll force you to connect some dark matter's effects on the galaxies, using some rotational curves and its role in the cosmology, and using lambda CDM. And the advanced part is basically the researching, obviously, researching the potential identity, and some questions to be met, like is dark matter a particle, or you can use some what do you say, telescopic observations, how the studies have shown it to be, or could it be a compact object in its role, or could it be more like a primordial BH or a black hole. So this is what your second topic will be. Cosmology, galaxies, and compact objects are covered here. And again, you can once again check for specific points um, uh, of approach that you need in your presentation. Now, these advanced elements that I've given are just advanced elements. Okay, these are not the only thing you should be focusing on. If you have these advanced elements in your presentation, you could probably have an extra point, or you could uh, you would be able to create a more in-depth conceptual understanding for the others as well. So these advanced elements are one part of it, but apart from that, you need to have some out of the box concepts that link all three of them. So your main idea is to link these three: synthesis, and to focus on dark matter from halo to horizon. These are your first two topics. Moving on, your third topic is Adrian feedback and galactic co-evolution. Now, here in this topic, you'll be researching how the very first massive stars, or how the massive stars during the stellar evolution died, and how did they create the first stellar mass black holes, which are again compact objects. And these black holes, how did they grow and merge to become some supermassive black holes? So it's from compact objects to supermassive objects. And now you will regulate some star formations in every major galaxy as AGN. Right. So here also we are taking stellar evolution, compact objects, and galaxies into consideration for our synthesis. And your topic 4 is also So once again, your advanced elements, you can consider them, could be a better understanding. But apart from that, please make sure that you have in general conceptual way of conveying the rest of your topic as well. Now, the epoch of reionization, or EOR, is one topic. That's your fourth topic. And it's moreover more like an advanced cosmology topic, right? So this has like a major part of it dealing with cosmology, wherein you should involve stellar evolution as well as galaxies. Now it's about the first light that the universe had after the cosmic dark ages, and you will be researching the population 3 stars and very first generation of stars, and how did the unique stellar evolution happen, and that unique stellar evolution is told because of the zero metal in it. And how did these zero metal or stellar evolutions have led to the deaths and eventually leading to some compact objects, if there are any. I'm just putting out ideas so you can look into it a little more, and you can come up with ideas. Right. And also, yeah, the EOR is one place where you can talk a lot about the radiations and explosions or feedback of these compact objects or black holes, etc., and how the ionization has happened in early universe, and how the galaxies or the first galaxies get their shapes. All these can come under EORs. Now, your fifth topic is the final eons of the universe. Now, this fifth topic you will have a better understanding of this fifth topic once we finish our upcoming session on Monday. But for now, you can have a quick look through all 5 topics, and you can decide how you want to approach your project. Right. So, topic 5, the final eons of the universe would point to or imply at the final fate of the universe, which is one of the topics we'll be dealing with in the upcoming session. And so this is basically the capstone. Okay, this topic is more like a conclusion to a lot of what do you say? I've only mentioned cosmology, stellar evolution, and compact objects here, but this is more like the end game of it all. So it'll obviously be touching the galaxies as well. So this topic will just club everything together in a new dimension. And
Wallpaper.
so
Wallpaper
this will
upload.
start with Lambda CDM, which we'll be looking into in the upcoming session, and Lambda CDM model, and that is in the cosmology. And you will trace the, some of the future history of all the matter, and how will stellar evolution end, and what will be the final state of all the compact objects, and what will happen to galaxies, once it's accelerated expansion, and some
Wallpaper.
what do you say, the expansion is accelerated to an extent where it may or may not be isolated, and it could create
ভাত
some
সাম্বার
empty
ছাড়া
dark
কিছুই
voids,
লাগতো
or
না
is there a
নর্মালি সব
possibility
খেয়ে
to be
চলে
created that way, or what could
ভাত
happen a
সাম্বার ছাড়া
few
কিছুই লাগতো না
billion years from now? Would there be emptiness, or would there be voids out there? So all these could be answered with this topic. So this is basically what your mini project 2 is all about. So you have 5 topics. You choose one topic, you inculcate all the synthesis that is given, and you try to put it out in an effective format, bring in more topics, and please don't repeat the topics that we have already taken in the previous sessions. You can refer to them, and you can have a quick glance over those topics, but don't particularly pick a topic from our previous sessions and try to present it as it is. You can add your own things. You can just make sure that you have the synthesis linked beautifully. So this is all about it, and you have 10 days to complete this project and for your presentations. Also, one more thing, I will be sending out an Excel sheet like we did on our first mini project. I'll be sending out an Excel sheet to see who is choosing what, right? So we don't want everyone to be choosing one single topic. And if there are any sort of majority playing in any particular topic, I may have to split that up among people, and we'll see. So you can, for now, I'll be putting up an Excel sheet, and you can um, fill those Excel sheet, and then we'll look at how the entire class is filling up the Excel sheet, and based on that, we'll split or keep it same. So try to, over the weekend, try to just type up these topics and see how interesting these appear to you. And you can choose your topic accordingly, and you can start your research on these.
তুমি এমনি
Hope that's clear.
কিছু মনে হলো বানালে ছাড়লে
All right. Okay. So, yep. So that's about it. This is today's topic. I just wanted to introduce you to this mini project too. So this is the end of the session. Since we don't have many people for today's session, I am going to be winding up soon. If you don't have any more doubts, we can wind up quickly. Gosh, wait, I may have to click a screenshot. Give me a moment.
আর তোমার তো তোমার কমর দোলাও তুমি ন্যাংটো নাচো তোমার কোনো ফায়দা নেই একটা কথা আছে না লেডিস ফার্স্ট সব জায়গায় তখন প্রত্যেকটা জায়গায় একটা ওগুলো ধরো লাইন আছে জেন্টসের লাইন টিকিট একটা মেয়ে ধরো আছে আনকমফোর্টেবল ফিল হচ্ছে সবাই বলবে তুমি আগে যাও তুমি আগে যাও নোট একটা ছেলে থাকতো
Yeah. So do we have any more questions, or do we call it a day? You can start if you have another 20 minutes for the session to end. So during the 20 minutes, you can start checking up on the topics. All right,
No
guys.
questions.
Can you show the
Sorry, come again.
No questions.
No questions. So hope you're clear with what you're supposed to be doing for your project.
Yes.
All right. So in short, just to sum it up, you have been given 5 topics, and each of those topic has an inculcation of at least 3 of the 4 courses that we did, right? So our 4 courses that we did were, this is for those of you all have joined late, we have completed stellar evolutions 2 topics, 2 sessions, galaxies 2 sessions, compact objects 2 sessions, cosmology is 1 session, and the next session will be conducted on Monday. Okay, but I just thought I'll give this PPT or this project before your Monday session so that you'll have the weekend to look through your project as well. Now, out of these 4 topics, you will have to inculcate at least 3. All right. So here, coming to the topics, you have 5 topics given to you. You can choose any one of these topics. And if you want to add, like apart from the 3 synthesis that I've provided, apart from that, if you want to add the 4th synthesis also, like for example, stellar evolution, compact objects, cosmology, and if you want to add about galaxies also here, you're free to do that. That's wonderful. But please make sure that if you have chosen any one of these topics, make sure that all the synthesis points covered here are explained or at least looked into during your presentation. Each of you will have 8 to 10 minutes to present, and yes, that's about it. So the synthesis is a very important part, and how effectively you convey the concept is very important, as well as if you have some new concepts or new development in the studies or something that's out of the ordinary way of presentation, you can have that. Also, it's very important that you add, I've put it up here in the brief. Excuse me. Yeah, so this brief will be sent to you as well. These are the evaluation focus, like everyone will be evaluated based on these 3 criterias majorly. And also the presentation rules include that you need to have a quantitative context, wherein whatever topics you're discussing about, you need to have diagrams or equation or a key parameter or a data plot, anything that will help you explain the topic in a more effective manner. So these quantitative context and the accuracy of these context will also be counted into consideration. And if you have any queries based on this, you can check with me or you can check with any sources that you have. Just make sure whatever you present is accurate to the point. And the evaluation focus should be in your mind. Yes, that's about it. And yeah, I'll be putting up these topics for your reference in the group. So that's all. If you do not have any more questions, we can call it a day.
Yeah, no questions.
Okay. All right. So thank you, everyone. Have a great day. Have a great night. And see you all on Monday. Please make sure you attend your Monday session, because that will give you the final wrap up to the topic of the minor project 2. So yes, see you all then. Bye-bye. Bye.
Bye, ma'am. Good night.
Good night.
Thank you, madam.
Good night, ma'am. See you.
Thank you.
Thank you, madam.
See you on Monday.
Thank you, ma'am.
Thank you. Bye-bye.
Thank you, madam. Very class.